All right. Good afternoon.
Oh yeah, I haven't got one. I'm surprised.
Any questions for yourself? All right.
When are we going to be seeing our tests back?
Hopefully by Monday.
Okay, alright, that's good.
I just finished first problem. I'm in the middle of second problem, so I'm gonna work on this tomorrow. And by Monday you should get.
How's it look? How'd the first problem go?
Let's be honest.
It was good.
That's good.
Yeah.
That's good. All right. Now, is that a weatherman good or is that? A...
No, it's better than what I expected.
Oh, well, that's excellent.
What were your expectations?
Actually, that's a good
20%, we did a 30%.
60%.
Oh, all right.
Wait, that was your expectation? We did better than that?
Yep.
Sweet. I'll take that.
Wait, he didn't say how much first problem.
Yeah.
61 is better than 60 on the first problem.
I got 6 degrees.
That's on the first problem.
I don't have chalk.
I just.
Let me go and grab some.
Someone has decided to write this just about piece of I hope so.
I saw it when you
Ask for a test.
Found it.
Draw an arrow to the top.
Found I?
That's a bad T too. There you go. There you go. Good job.
All right. Today we are gonna finish acceleration analysis. Then I'll go through the homework 8 problem 1, just some explanation before we'll start working on that. Then, if we have time, we'll start talking about force analysis, which is the last topic before we start kinematic synthesis or design of the mechanism. All right. Yesterday, thank you. Yesterday we finished acceleration analysis for an offset slider crank. Today we are gonna work on four-line mechanism. So if this is O2A, B, and O4, theta 2, theta 3, and theta 4. This is A, this is B, C, and D, and this is the way that we form the vector. So O2A plus AB, it's gonna be O2O4 plus O4B. So for displacement analysis, we got these two equations: A cosine of theta 2 plus B cosine of theta 3 equals to D plus C cosine of theta 4. And A sine of theta 2 plus B sine of theta 3 equals to C sine of theta 4. X component, Y component. For velocity analysis, what we did, we just differentiate them. An X component equation is going to look like negative a theta dot 2 sine of theta 2, negative b theta dot 3 sine of theta 3 equals to negative c theta dot 3 sine of theta 4. And y component is gonna look like a theta dot 2 cosine of theta 2 plus b theta dot 3 cosine of theta 3 equals to c theta dot 4 cosine of theta 4.
That exponential c theta dot 4.
Thank you. Yes. So on displacement analysis, theta 2 usually is given. We are solving for theta 3 and theta 4, but you might be given with theta 3 or theta 4, you are gonna solve for the other two. After you are done with displacement analysis, you can do the velocity analysis. So for velocity analysis, theta 2 and angular velocity of link 2 is given. You are looking for angular velocity of link 3 and link 4. After you are done with velocity analysis, you are ready to do acceleration analysis. Theta 2, theta dot 2, and theta double dot 2 are input. They are given. Angle of theta 2, angular velocity of link 2, and angular acceleration of link 2 are given. The variables are in acceleration analysis are theta double dot 2, theta double dot 3, and theta double dot 4. Or alpha 2, alpha 3, and alpha 4. The other notation for angular acceleration. So what will be nouns? These are the nouns plus other information that we got from displacement and velocity analysis, and we are solving for a noun. Theta double dot 3 or alpha 3, and theta double dot 4 and alpha 4. Good. So we are gonna differentiate velocity equation to get acceleration equation. So let's do for the last time to practice to differentiate equation. So just for the first one, differentiate this with respect to time. This is the last time that I'm asking you to do in the class. Next time is going to be the exam. So I just want to make sure that you are prepared for that. So differentiate this with respect to time, and then I'll ask a couple of. Anything which is varying with time, it's going to have a derivative with respect to time.
It's close to sine.
Number 5. What would be the derivative of the first term after this? It's the reason that I'm asking you to do the class activity in the class, because I just want to see what kind of difficulty or challenge you may face for those problems. So I'm not necessarily looking for a correct answer. I just want to see what would be your approach to the problem. So do you have any idea about the first term? If we differentiate that. Okay, let me call someone else. Number 34. What do you think? Alright. Number 18. The first term, just okay. Omega 2 squared. All right.
Let's go right. Here we go.
Thanks, Carl. Don't run out of space.
Theta, okay. Sine of theta dot 2.
What is that?
No
No doubt.
No doubt.
No doubt.
It's just an I or something, dude. I don't know.
It's I.
Alright, there we go.
Thank you. All right, so it seems a couple of you have difficulty with differentiating the equations. So it's time to ask me if any parts of that is not clear. So when you want to differentiate any equation, you start from the first term. This term is constant, so we don't differentiate that. So we keep it there, negative a. So second term, omega 2 or theta dot 2. It may change with respect to time, so we should differentiate that with respect to time. Negative a, derivative of theta dot 2 with respect to time, times whatever term left, sine of theta 2. I differentiate this term, now I will look at this term. Theta 2 is varying with time, so I should differentiate that. Negative a, theta dot 2, derivative of sine of theta 2 with respect to time. I'm just looking at the first term. I'm gonna write down the second term and the third term later. So this term, the derivative of velocity, derivative of theta 2 with respect to time is gonna be theta dot 2 or omega 2. Now derivative of velocity with respect to time it's always acceleration. So, and it's a derivative of velocity with respect to time, it's gonna be acceleration. Negative a, theta double dot 2 or alpha 2 sine of theta 2. Second term, derivative of sine of theta 2 with respect to time. These two are not the same, so we should use the chain rule. Derivative of sine of theta 2 with respect to theta 2 times derivative of theta 2 with respect to time. We call it chain rule because these two variables are not the same. Derivative of sine with respect to theta is going to be cosine of theta 2. Derivative of theta 2 with respect to time, it's going to be theta dot 2. So negative a theta dot 2, I have one theta dot 2 here, cosine of theta 2. So this times this is going to be theta dot 2 squared. Any, yes?
Do you mind if we just go from first to the end? Do we have to write out all?
No, no, I just wanted to show the steps if someone has difficulties to follow up the steps. So for the second term, I'm not gonna write it down. I'll just write the final derivative. So we are done with the first one. I'm just rewriting first term. Right here, x component, negative a, theta double dot 2 sine of theta 2, negative a theta dot 2 square cosine of theta 2. I'm done with the first term. Second term, b is constant. I differentiate the second term, which is theta dot 3. Negative b, derivative of theta dot 3 with respect to time, it's gonna be theta double dot. And derivative of sine of theta 3 is gonna be theta dot 3 cosine of theta 3. I'm done with the second term as well. Last term, negative c theta double dot 4 sine of theta 4, negative c theta dot 4 square cosine of theta 4.
Dr. Gaffney,
Yes.
in the last term of the first line, we did theta double dot squared.
Yes. It should have been. Thank you. Alright, if you look at the first equation, the unknown terms are theta double dot 3 and theta double dot 4. So what I'm gonna do, I'm gonna move theta double dot 4 to the left side. I'm gonna move the other terms to the right side and simplify this equation by moving all unknowns to left side, all unknowns to the right side. So negative b theta double dot 3 sine of theta 3. This negative when it goes to the left side, it's gonna be positive c theta double dot 4 sine of theta 4 equals to. This negative should change to the positive. This negative should change to the positive. And this negative should be changed to the positive as well, plus b theta dot 3 square cosine of theta 3. And I leave this on the right side. Negative c theta dot 4 cosine of theta 4. Any question on this? Yes. This term? This term is unknown. I move it to the left side. I change the negative sign to positive. This term is known. I keep it there. I'll keep the sign same. So, but this one, and this one, since I move to the right side, this sign is gonna change to positive. I'll keep this negative because I didn't change this time. I'm writing the second equation, derivative of the second equation. Just follow the terms that I'm writing. The first term is going to be a theta double dot 2 cosine of theta 2 cosine.
Should the last term be squared?
Oh yes, thank you. Negative a theta dot 2 square sine of theta 2 plus b theta double dot 3 cosine of theta 3 is it positive? Yes. Negative b theta dot 3 square sine of theta 3 equals to negative c, positive c theta double dot 4 cosine of theta 4, negative c theta dot 4 square sine of theta 4. This is equation 1. Equation 2, again, theta dot 3 and theta double dot 3 and theta double dot 4 are unknowns. I move this term to the left side, and I move this one, and this one to the right side. I'm gonna get b theta double dot 3 cosine of theta 4 minus c theta double dot 4 cosine of theta 4 equals to, this is gonna be negative. This is gonna be negative, positive. This term should change to positive. And I don't change the sign of this. Negative c theta dot 4 square sine of theta 4. So the slide has changed theta double dot 2 to alpha 2. So they are the same, and theta dot 2 to omega 2. Similarly for this. Now, if I want to write this system of equation in a matrix form, I'm gonna have a coefficient matrix, variables, and the constant parts. So matrix A times matrix X equals to matrix P. Matrix A is the coefficient. Matrix X would be our unknowns, which are theta double dot 3 or alpha 3 and theta double dot 4. Angular acceleration of link 3 and angular acceleration of link 4. And right side is going to be the constant part. The coefficient of theta double dot 3 is negative b sine of theta 3. S theta 3. Coefficient of theta double dot 4 is positive c sine of theta 4. Positive c sine of theta 4. S theta 4 means sine of theta 4. And on the right side, just write this part. A alpha 2 sine of theta 2 plus A omega 2 cosine of theta 2 plus B omega 3 squared cosine of theta 3 minus C omega 4 squared cosine of theta 4. Similarly, for the second equation, the coefficient of theta double dot 3 is positive B cosine of theta 3 and negative C cosine of theta 4. And right hand side, we just need to have these four terms. We are looking for this column. We know all terms in matrix A and all terms in matrix B. Matrix B it's gonna have two rows, one row, second row, and one column. Matrix A has two row, first row, second row, and two columns. Two rows and two columns. This column and this column. It's 2 by 2, 2 by 1, 2 by 1. In velocity analysis for the four-bar mechanism that we derive the equation for velocity analysis.
Dr.
yeah,
Gopsi,
Sorry.
For the matrix, can you explain why each coefficient goes in the position that it does for matrix A? So why the coefficient of theta double dot 3 goes in position 1, 1, and the coefficient of theta double dot 4 goes in position 1, 2?
Sure. I mean, you can. Let's back to this. So, do you want me to switch the?
Yeah,
okay,
it's like, can you just go through and
Sure.
explain the positions if you were to switch that?
Yeah.
A lot of people haven't taken linear
Sure.
yet.
Let me just switch the location of these two and see what's gonna happen to this matrix. I'm gonna have right here. Theta double dot 4.
Yep.
Theta double dot 3. Then in this line, I need to fill out these two. Okay? And first equation, what would be the coefficient of theta double dot 4? Just write it down on the first place. So the coefficient of theta double dot 4 is C sine of theta 4. So it comes here, C sine of theta 4. First term, first variable, first unknown, first location. And second should match with theta double dot 3, which is negative B sine of theta 3. Similarly, second row. What for the first place, I need to see what would be the coefficient of theta double dot 4. Just look at this. Theta double dot 4 has negative C cosine of theta 4. And coefficient of theta double dot 3 is gonna come here, which is b cosine of theta 3. Just compare with this, switch the position of these two and these two. Is that clear?
Yeah.
So as I said, that's a good question. You can choose theta double dot 3 or theta double dot 4 for this position, for this location, or vice versa. But if you choose theta double dot 3 here and theta double dot 4, then you should see what would be the coefficient of first term here, and you should have it here, and what would be the coefficient of theta double dot 4 here, and write it down there. Good. So if we look at the velocity equation for 4-bar mechanism, we differentiate the velocity equation and we end up with this system of equation. Matrix A, the coefficient is exactly same as the coefficient of acceleration equation. Negative b sine of theta 3, c sine of theta 4, b cosine of theta 3, negative c cosine of theta 4. But as you see, the constant part is totally different. Here we only have a omega 2 sine of theta 2. For acceleration, we have 1, 2, 3, 4. Summation of 4 terms. And here 1, 2, 3, 4. Summation of 4 terms. So when you are done with velocity analysis, you only need to calculate the matrix B, because matrix A already has been calculated. So, just example, for a given mechanism with the length of A, B, C, and D, we would like to do acceleration analysis when the mechanism is at the angle of 57 and it's rotating at the speed of 10 radian per second. We didn't say it's clockwise or counterclockwise. If we didn't say and it's positive, means it's counterclockwise. So it's rotating at this direction when it's at angle of 57. And angular acceleration of length 2 is negative 15 radian per second square. Negative 15. Do the acceleration analysis. I'm gonna do this for only open assembly mode. For the open assembly mode, we did the displacement analysis and we could get theta 3 equals to 16.85 and theta 4 equals to 121.66. And for this one, for this mode, theta dot 3 or omega 3 was negative 4.67 radian per second. And theta dot 4 or omega 4 is 4 radian per second. So the coefficient of A, the matrix A for the acceleration analysis is going to be same as the matrix A for the velocity. So I can use when I did for velocity analysis, I calculated matrix A, which is negative 1.739 for the first node, 4.256, 5.742, and 2.624. So I'm just need to calculate matrix B, which is this vector. A is B is 6, C is 5, and D is 10. So A is 3 times theta dot dot 2, which is negative 15, times sine of 57, plus A omega 2 square, omega 2 is positive 10, 10 square, cosine of theta 2, which is 57, plus B, which is 6, times omega 3 square cosine of theta 3, which is 16.85, negative 5 times omega 4 square cosine of theta 4. Second by negative A, which is negative 3 times negative 15 cosine of 57 plus 3 times omega 2 sine of 57 plus B times negative 4.67 squared sine of theta 3, and last term is negative C omega 4 sine of 121.66. It just needs calculation. If you do that, you will end up to this to 292.89, 245.95. Any question on this? So you have matrix A times matrix X equals to 292.89 and 245.95. So I'm just still working. Matrix A is negative 1.739, 1 space 4.256 semicolon. It goes to the second line, 5.742, 1 space 2.624. This is matrix A. Vector B is 292.89, semicolon 245.95. It matrix B. Now I can write A backslash B. So the value that you will get, the first one goes to theta double dot 3, and second one goes to theta double dot 4, which are 9.59 and 72.73. The unit is radian per second squared because it's angular acceleration. It's positive means both they are moving in, that they have a counterclockwise acceleration. If you switch these two, if you want to switch these two, your matrix A is gonna change to 4.256, the coefficient of theta double dot 4. And negative 1.739. And here just switch this to 2.6, 24, 5.742. Matrix AA, I'm using AA. 4.25, 6, negative 1.739, and second line 2.65, 2.624, and 5.742. Now if you AA backslash B, you should just get first one up and second one as a second question. Any question on this? So, all right, let me look at the homeworks. First problem. First problem is a crank rocker, 4-bar crank rocker, something like this, but it's a crank rocker. In homework 4 and homework 7, you have written the code to do the velocity and acceleration analysis, velocity and displacement analysis for this. In this problem, I'm asking you to do acceleration analysis for the input angle of 0 to 360. Not only for one theta 2, I would like to see if theta 2 is varying from 0 to 360 in a step of 5, 0, 5 degree, 10 degree, 15, all the way to 360. Find the acceleration of point P. Point P is somewhere here. If you back to homework 6, you will find the acceleration of, you can find the information for point P. After you find the acceleration of point P for all this input angle, locate or tell me at which input angle we are going to have the maximum magnitude for acceleration of point P. So it tells me at which input angle point P is going to see the maximum acceleration or maximum force, because force is mass times acceleration. And also you need to plot the angular acceleration of link 3 and 4 versus input angle of theta 2. And when you plot that, you can locate the input angle in which we have maximum omega alpha 3 or maximum alpha 4. Problem 2 is a 5-bar mechanism. We have done displacement analysis. I ask you to differentiate displacement equation to find velocity and acceleration equation and solve for numerical results. And problem 3 is same as homework 6 and 7, I believe. This time I'm asking you to do the acceleration analysis. You should use the information that we provided on this problem. Alright. I will collect the homeworks.